In question number 16, it says that the acceleration displacement graph of a particle executing simple harmonic motion is shown in the figure. The time period of oscillation is where A and B are maximum value of displacement and acceleration respectively. According to the question, A is the maximum value of displacement, that is amplitude, and B is the maximum value of the acceleration. And we know that the maximum value of the acceleration in SHM is equal to omega square A, where A is the maximum value of displacement, that is amplitude. So according to the question, maximum acceleration is B, amplitude is A, so we can write omega will be equal to root under B by A. So this is our omega. But what we have to calculate? We have to calculate the time period. So we know that time period will be equal to 2 pi by omega. So we can say that our time period will be 2 pi square root of A by B. So my option number 2 will be the correct choice. Now let's move to the question number 17. In question number 17, it says that a particle is subjected to SHM as given by equation x1 is equal to A sin omega t and x2 is equal to A sin omega t plus pi by 3. The maximum acceleration of the resultant motion is. We know that the maximum acceleration in SHM will always be equal to omega square A, where A is the amplitude. But here, since two SHMs are superimposed, so we can say that the new amplitude will be the resultant amplitude, right? So how do we calculate the resultant amplitude? Since the amplitude of one SHM is A, other SHM is A, and the phase difference between the SHM is pi by 3. So we can say that our resultant amplitude will be simply A square plus A square plus 2 into A into cos pi by 3. This is the formula of the resultant amplitude. We know that cos pi by 3 is what? 1 by 2. So when you will solve it, you will get root 3A. So this is our resultant amplitude. So we can say that our maximum acceleration will be omega square into root 3A. So we can also write it root 3 omega square A. So our option number 3 will be the correct choice. Now let's move to the question number 18. In question number 18, it says that a spring block system of mass m and spring constant k is placed at the horizontal frictionless surface as shown in figure. A bullet of mass m is fired towards the block with speed v0. If it is embedded in the block, then the amplitude of the oscillation will be. So we know that the amplitude is the maximum distance of the object from mean position or equilibrium position. Since this block is on horizontal surface, so we can say that when spring is in natural length, right, that will be our equilibrium position or mean position, right? So this is our equilibrium position, right? And since at equilibrium position net force is 0, right, a bullet of mass m is colliding with the block. So we can say that our momentum will be conserved because at equilibrium position net force will be 0. So we can write from conservation of momentum mv0 will be equal to, since the bullet gets embedded, so that means they are combined, so the combined mass will be m plus m, and let's say our final velocity is v. So from here we can say that our final velocity just after the collision will be mv0 upon m plus m. This is our velocity. Now by this velocity, this whole system will start moving, and we know that at maximum displacement, that is at amplitude, the block will come to at rest. So we can say that, let's say it travels a distance a and now it is at rest. So this A is called the amplitude of the SHM, right? So if I use the conservation of mechanical energy, right? So initially at equilibrium position, there was no compression in the spring, only there was velocity. So we can write the initial kinetic energy plus initial potential energy will be equal to the final kinetic energy plus final potential energy. This is our conservation of mechanical energy. So since initially there is no compression in the spring, so initial potential energy will be 0. But since whole system is moving with speed v and we have calculated the velocity v, so we can say that initial kinetic energy will be half m plus m into v square. This is our initial kinetic energy. And finally, as you can see that at maximum displacement, its velocity will become 0, because at maximum displacement at amplitude the SHM stops, right? So the final velocity is 0, so the final kinetic energy will be 0. And what will be the final potential energy? Since spring gets compressed by a distance a, so we can say that our final potential energy will be half Ka square. So by this solving this, we can say that our amplitude will be equal to m plus m by k square root into v, and we have already calculated the velocity v. So if I put the value of v, we can write mv naught upon m plus m, this is our velocity v, and square root of m plus m by k. This is our maximum displacement, and that maximum displacement is also called the amplitude. So this is our final answer. So we can say that our option number 3 will be the correct choice. Now let's move to the question number 19. In question number 19, it says that the figure shows snapshot of a wave traveling along a taut string in positive x direction. So that means velocity of the wave is positive, right? Various points have been marked on the string. Select the correct option. We have to choose the correct option regarding motion of the points at the instant shown. So we have to find the motion of the point, that means motion of the particle situated at A, B, C, D, E, right? So we know one relation, that is velocity of any particle will be given by minus dy by dx into velocity of wave. And we know that dy by dx is also gives you the slope. So we can write slope into velocity of the wave. So this is our velocity of any particle p. So now if you look at the slopes, at point A, the tangent will be downward. So we can say that slope will be negative. At point B, the slope will be 0. At point C, the slope will be positive. D, slope positive. E, slope 0. So now let's read the options. Question says that points C and D are moving in opposite direction. Since C and D has the same sign of slope, that means positive slope. So if the slope is positive, velocity of the wave is positive. So we can say that velocity of C and velocity of D will be negative, because there is a negative sign in front of this, right? So velocity of C and D will be negative. Similarly, if you look at the velocity of A, since at point A slope is negative, so slope is negative and the velocity of wave is positive. So negative positive will make you negative, and this negative will make it positive. So we can say that the velocity of A will be positive. Second option says that acceleration of point B and E is 0. So acceleration of point B and E, since B and E are at extreme position, and we know that at extreme position acceleration is maximum, and that is omega square A. So this is also wrong. This is also wrong because they are in same direction, not opposite direction. They are both are negative, right? Third option, velocity of point C is 0. So point C is at the midpoint, that means at mean position. If it is at mean position, so the velocity will be maximum, and that is equal to A omega. So this is also our wrong. Option 4 says point A and C are moving in opposite direction. Velocity of A is positive, velocity of C is negative. So yes, they are moving in opposite direction. So this is our correct. And we have to choose the correct option. So we can say that our option number 4 will be the correct choice. Now let's move to the question number 20. In question number 20, it says that which of the following two wave equations can form a stationary wave? And we know that to form a stationary wave, the wave must have same frequency, right? And they must be moving in opposite direction, right? Moving in opposite direction. These two conditions must be satisfied, right? So as you can see that this 1 is plus moving in negative direction, 2 plus this is also moving in negative direction. So 1 or 2 cannot make a stationary wave. Yes. Again, let's see 3 and 4. So 3 is negative, 4 is also negative. So both are moving in positive direction. So they will not make a stationary wave. If you look at option 3, 1 and 4. So 1 has a positive and 4 has negative. That means 1 is the moving in a negative direction and 4 is moving in a positive direction. So yes, they will make a stationary wave. So my option number 3 will be the correct choice. Now let's move to the question number 21.